Hello. This video is about halide ions and sulfuric acid. It's very much part of redox chemistry, and it's a very tricky part that students tend to get wrong over and over again. And it just seems to baffle them. But hopefully this little video will help you get your head around it. Ever since I've started teaching like this, people have got better at it. So I hope this is going to work for you over the video. Yeah, it works well in class, but we'll see. First thing we need to realise then is, what is a halide ion? Well, a halide ion is a halogen that's gained an electron. So these are halide ions now. This is chloride, bromide, iodide, fluoride, astatide. They are halide ions. They're ions, it's got a charge, halide. They come from the halogens. Concentrated sulfuric acid is H2SO4. So this section is about very specific reactions between halide ions and sulfuric acid. And the examiner, therefore, in the exam questions, will ask you questions to do with halide ions and sulfuric. So once you pick up on these clues, it will be a lot easier. So what I'm going to start off with then is just some general knowledge. I'm going to do which you should have learned in previous work. Halogens. I'm going to start off with the halogens, and then I'm going to look at the halide ions. Okay. So if we look at the halogens are F, Cl, Br, I, and I could put astatine down, but I'm not too bothered about that. All right. If I was to represent the size of these halogens, if they were atoms, you would have fluorine would be the smallest, chlorine a bit bigger, bromine larger still, and iodine larger still. Now the halogens, if I was to go to GCSE electron configurations, 2,7, 2,8,7, 2 blah blah blah, 7, 2 blah blah blah, 7. They've all got 7 electrons in their outer shell. But as you go down the group, they increase in the number of shells. So 2, 7, 2, 8, 7, 2, 8, 18, 7, and so on. So there's an extra shell. As you go down the group, they increase in the number of shells. So you also know from GCSE that these halogens are quite keen on gaining an electron to get this full outer shell, and at A-level we say to get a stable electron configuration. So if you were to look at all of these 4 halogens, and I was to say which of these 4 is the best at gaining electrons, I hope, so here's an electron, I hope you realise that the fluorine is the best at gaining electrons. So if I ask you why, and this is a GCSE question, why is fluorine the best at gaining electrons? In other words, you can say, why is it the most reactive halogen? Well, it's the most reactive halogen because it gains electrons the most easily, because its nucleus is closer to the outer shell, and it's got fewer shells, so there is less shielding between the nucleus and the outer shell. So electrons are attracted more strongly to the nucleus. If you take iodine, for example, iodine is not very good at all at gaining an extra electron because the nucleus is a long way from the outer shell, and also the outer shell is very well shielded from the nucleus. So what you find then is, as you go down the group, I'll do it this way around. As you go up the group, they get better at gaining electrons. Well, if they get better at gaining electrons, let's make this a little bit better now. We know that oxidation is loss and reduction is gain. So as you go up the group, they are reduced more easily. If they are reduced more easily, oxidizing agents get reduced. Oh, right. So that means that fluorine, out of all of these, is the best oxidizing agent because it gains electrons more strongly. Fluorine is the best oxidizing agent. Fluorine, the halogen, is the best oxidizing agent because it gains electrons the easiest. Iodine is the worst oxidizing agent because it gains electrons the least easily. So, anyway, if you look on the periodic table, it's things that can help you remember. If you look at the halogens, that's group 7, all of these. There's a big clue to tell you that fluorine is a very good oxidizing agent. Well, it lives next to oxygen, and hopefully you realize that oxygen is a good oxidizing agent. So, in group 7, the halogens, best oxidizing agents, and down the bottom, worst oxidizing agent. Best at gaining electrons, very good at gaining electrons, not quite as good at gaining electrons, terrible at gaining electrons, and so on. Okay, so I hope we've got that clear. The halogens are best oxidizing agents here at the top because they are the smallest atoms. Just to show you something, by the way, fluorine doesn't tend to go round as single atoms. Hopefully you do realise that fluorine goes round in pairs. So what tends to happen here is fluorine, it will split into 2 atoms, and each atom will gain an electron. So one fluorine will form 2 F minuses. Alright, so you just need to be aware that fluorine is a diatomic molecule. Okay, so we've got that, and that was a bit of revision. That as you go down the group in the halogens, they get less good at gaining electrons. So that means the best oxidizing agent is fluorine. So now we've got a situation there, which is the basis for this video, the halide ions. So now I'm going to draw F minus, Cl minus, Br minus, and I minus. So we're now in a situation, I'm just going to draw the 7 electrons that it had on its own, plus this extra electron that it's gained. I'm going to draw that as a dot. Chlorine is a bit bigger, 1, 2, 3, 4, 5, 6, 7, and there's the extra electron that it's carrying. Bromide, that's meant to be a bit bigger still. Maybe should have made it more obvious. 1, 2, 3, 4, 5, 6, 7, there's the extra electron. And here's iodide, I've probably overdone that one. 1, 2, 3, 4, 5, 6, 7, and there's the extra electron. Can we just imagine that bromide's a little bit bigger, please? No, tell you what, I'm going to draw it again. Didn't make it that much bigger, but anyway. Okay, so can you imagine then that we started off with the halogens and they've all gained their electrons. So now you're in this situation, you've got the halide ions. They're called halides because this is fluoride, chloride, bromide, and iodide. If I was to ask you then, in all of these situations, which of these halide ions is holding on to its extra electron the most tightly? Which one is holding on to its extra electron the most tightly? Now I hope you realise that fluoride is holding on to this extra electron really, really tightly because it's the smallest ion. All of these outer shell electrons are closest to the nucleus. In other words, the fluorine gains an electron very easily and then it will not let it go. A fluoride ion is not going to let its extra electron go very easily at all. It's grabbed it and it wants to keep it. Chloride, there's an extra shell of electrons in there. It also gains an electron pretty easily. In other words, chlorine gains an electron easily. It was a very good oxidizing agent. And once it's gained that electron, it doesn't want to let it go because there's a strong attraction here. Bromide. Well, bromine, it didn't gain an electron particularly well to become bromide. It doesn't hold on to this extra electron that easily. So what can happen here is this extra electron can leave again. In other words, bromide can quite easily become bromine. More precisely, that can happen. And iodide wasn't that fussed about getting the electron in the first place. So if you have an iodide ion, this extra electron here can leave quite easily. So what we're saying here is, if you've got the halide ions, these 4 ions here, iodide ions are actually really, really good at giving electrons to other things. The iodide ions are excellent at losing this extra electron. Iodide ions are excellent at losing electrons. If you lose an electron, you are oxidized. And if you get oxidized, you are a reducing agent. What that means is, if I draw an arrow down the side here, you can just about see, actually I'm going to draw it down here. Halide ions, the best reducing agent is an I- ion because it can release its extra electron really easily. If you were a chemical and you wanted to get an extra electron from something, you would go to iodide and not fluoride. Fluoride will hold that extra electron really, really tight and not give it away. Iodide isn't that bothered. It will release that extra electron quite easily because that extra electron is a long way from the nucleus and it's very well shielded. Okay, so on the periodic table, as you go, so this is the best oxidizing agent. And then the reverse of this, when you put a little minus charge on them, I- is the best reducing agent. So fluorine is the best at gaining electrons. Fluoride is the worst at losing electrons. Iodine is the worst at gaining electrons, but iodide is the best at releasing electrons. You've also got astatide below there as well. Okay. So that's important. I've taken 10 minutes there to explain this really, really important bit of chemistry. So if I wanted to go to the cupboard and if I wanted to get a chemical that was a good oxidizing agent, I would choose fluorine or maybe chlorine. They're good oxidizing agents. If somebody said to me, have you got a good reducing agent? I might go and get some iodide ions. So I can't just get iodide ions on their own, but maybe I'd get some NaI, some sodium iodide. The iodide ions in here are very good at losing their electrons. Sodium iodide is an excellent reducing agent, as is potassium iodide. Sodium bromide, Br, is a good reducing agent because it's got Br minuses, which are good at releasing their electrons. All right. So that's a little setup there for the rest of this topic, which is talking about these reactions between these halide ions, in other words, these reducing agents, and concentrated sulfuric acid. Now, the reason we're using concentrated sulfuric acid, the sulfur in sulfuric acid has got an oxidation state of +6. And what that means is that the sulfur has got quite a positive oxidation state. In other words, it's quite keen to gain negative electrons. So the crux, the hard bit about this topic is understanding that all we're doing here is we're going to do a series of experiments that prove this little bit of theory, that prove that iodides are the best reducing agents and bromides are okay reducing agents, and fluoride and chloride do not want to let go of their electrons. So what I'm going to do now is I'm going to download this little video, or upload, this little video, and the second part will be putting this into action. So the second video will be showing you some experiments between halide ions and conc sulfuric that prove that the iodide is the best reducing agent. Okay?